So in this lesson, we're going to be solving trigonometric equations. We're going to be solving equations that have the x, the variable, inside of a trigonometric function. So it's going to be an x inside of a sine function, or inside of a cosine, or in front of a tangent function. So we're going to have to get that variable out, and we're going to have to find all of the values of that variable, of x, that work in that particular equation. And so the slide in front of us here hopefully looks familiar because it's from our inverse trigonometric functions notes. And so at that time, when we were looking at these inverse trigonometric functions, for example, for inverse sine, we saw that we observed that we could get infinite angles that had a particular sine ratio, but we limited ourselves to just one answer. And so in the case of inverse sine, we limited ourselves to just an answer that was between negative 90 and 90, or in radians between negative pi over 2 and positive pi over 2. In the case of inverse cosine, we said we were going to limit ourselves to being between 0 and 180, because that's how we captured all of the possible cosine ratios, all the possible x coordinates from the unit circle. So from 0 to pi if we're talking about radians. And then for tangent, we said we were going to limit ourselves just to answers that were between, again, negative 90 and 90, between negative pi over 2 and positive pi over 2. Because again, the idea there was we wanted to make sure that when we found the inverse sine of something, when we had some sine ratio, we all wanted to make sure that we got the same answer. So in those circumstances, when we're talking about an inverse function, for every input, for every possible ratio that we plugged in, we were only allowed to get one answer out. But when we're solving an equation, like we're going to be seeing in these notes, we don't want just one answer. We want all of the possible answers. We need to make sure that we get every value of x that works in the equation, not just one of them. And so what's going to happen is we're going to have to build a mechanism for us to be able to find that infinite set of solutions using the inverse sine or inverse cosine or inverse tangent as kind of the starting point, and then building out from there. So take, for example, an equation like y equals 2 times the cosine of x plus 1. And so I've cheated and I've used Desmos here to help sketch the graph of that function. And so let's say we want to know all of the places where y equals 2. And so what we can do is we can graph the equation like I have, the cosine wave that we see in front of us. And then we can graph the line y equals 2. That's the blue line going across our graph. And then we can just use the intersect tool. If we're working on our graphing calculator, we can just use the intersect tool. But on Desmos, we can just click on those points. And we can see I've identified the first 4 locations where the two graphs intersect, meaning that we can see what value of x, so pi over 3, 5 pi over 3, 7 pi over 3, 11 pi over 3, what value of x we could plug into that function and get an output of 2. So basically what we're doing is we're saying, let's solve this equation. Let's solve that equation. Let's find the values of x that make that work. And so one way that we can do it is by using a graph like this. And we can see that those aren't the only 4 places. We have another point right here. We have another point right here. And since this cosine graph goes on forever to both the left and to the right, and this horizontal line at y equals 2 goes forever to the left and to the right, we're going to have an infinite number of answers. Now when we solve the equation using algebra, we're going to have to use an inverse operation to get that x out from inside of the cosine. But the inverse trigonometric function that we studied before would only give us one answer, and yet we can see in front of us here that we're going to have infinite values of x that we could plug into this equation that will give us this output of 2. So to find this infinite set of answers, we have to start with that inverse cosine value and build out from there. And so the way that we do that is by using what are called the arc relations, or in the case of cosine, the arc cosine. It's an awkward name, but we'll go with it. And so what we can see is we have this definition of this arc cosine in front of us here. So the arc cosine takes the one answer that we get from the inverse cosine and builds up an infinite solution set from there. So if we kind of construct it, we can imagine we take the inverse cosine of whatever ratio we have, we get that one angle, we get that one answer. And then what this arc cosine does is it says, all right, I'm going to take that one answer, and I'm going to throw a plus or minus in front of it. And the reason we throw the plus or minus in front of it is if we imagine, let's say this is our angle here that has some x coordinate right there. Well, if I rotate the opposite direction, that exact same angle, just going in the negative direction instead of in the positive direction, I'm going to end up with an angle that has the exact same x coordinate. So if I rotate in the positive direction or if I rotate in the negative direction, I'm going to get the exact same cosine ratio, the exact same x coordinate on my unit circle. So that's why we take that one answer that the inverse cosine gives us and then throw a plus or minus in front of it, because if I rotate in the positive or the negative direction, I'm going to have the same cosine ratio. And then to capture all of the angles that are coterminal with those two angles, I'm going to add that plus 2 pi n, meaning I'm going to add multiples of 2 pi so that I capture all of the infinite answers, all of the infinite angles that have that cosine ratio. So how does this work using this arc cosine to actually solve an equation instead of using the graph and the intersect tool that we saw up above? How are we going to generate those same x values that we see calculated for us automatically using algebra? So the equation that we have graphed up above is that y equals 2 cosine x plus 1. And what we said is we want y to equal 2. So really this is the equation. 2 equals 2 cosine of x plus 1. That's the equation that we want to solve for x. And so the first thing it says there in our list is we've got to isolate the cosine function using our regular algebra techniques. So I need to subtract 1 from both sides. I'm just going to isolate that cosine of x. We get 1 equals 2 times the cosine of x. And then we can see that we've got to get rid of that 2. So I'm going to divide both sides by 2. And so we end up with 1/2 equals cosine of x. So I've got that cosine of x isolated. I've succeeded in step 1. So now my problem is that the x is trapped inside of the cosine. So I need to get it out. And so we're going to use this arc cosine, which is going to undo the cosine. I'm going to take the arc cosine of both sides. So we think of this as we're going to have the arc cosine of the cosine of x equals the arc cosine of 1/2. So I've just taken my equation and I've just taken the arc cosine of both sides. And I just reversed it so that the 1/2 would be on the right and the cosine of x would be on the left. And so by definition, this idea that arc cosine undoes cosine. So these are essentially going to cancel each other out over here on this left-hand side. And so that means we're going to be left with x. And so then on the other side, we still have this arc cosine of 1/2. And so what does that arc cosine of 1/2 mean? Well, that's where this definition right here comes in. Is I'm going to rewrite this arc cosine of 1/2 as plus or minus the inverse cosine of 1/2 plus 2 pi n. So I'm going to take x equals plus or minus the inverse cosine of 1/2 plus 2 pi n. Again, the idea here is I've got this one answer that the inverse cosine is going to give me. I'm going to take that one answer, I'm going to throw the plus or minus in front of it, and then I'm going to add multiples of 2 pi to each of those in order to generate that infinite list. And so the unit circle is going to be a handy piece here. So we take the inverse cosine of 1/2, and so that is pi over 3. So I'm going to have plus or minus pi over 3, so the inverse cosine of 1/2 is pi over 3. I still have my plus or minus in front of it, and if we imagine on our unit circle, if I rotate the positive direction or the negative direction, that pi over 3 distance, they're going to have that same 1/2 as the x-coordinate, plus 2 pi n to capture all of the infinite angles that have that same x coordinate. And so this is what we refer to as our infinite solution set. That is all the angles. Pi over 3 plus multiples of 2 pi and negative pi over 3 plus multiples of 2 pi is our infinite set of answers, infinite set of angles that have that cosine ratio. So the question is, how do we get from this infinite solution set, this answer that represents all of the possible values of x that work in that equation, to the specific examples that we saw on the graph here? So how do we get these answers of pi over 3 and 5 pi over 3 and 7 pi over 3 and 11 pi over 3? How do we get those specific answers? Well, to make sure we understand what this n represents, this n is just all of the possible integer values. So what I'm going to do is I'm just going to plug in integer values of n starting from 0 and then figure out what does that expression clean up into. So if and probably the best way for us to do this is to split this up into pi over 3 plus 2 pi n and negative pi over 3 plus 2 pi n. And so I'm going to plug in 0 for n to start off with and see what answer I get. So if I plug in 0 for n right here, I'm going to get pi over 3 plus 2 times pi times 0, so just pi over 3. And so if you'll recall from that graph, that's one of our answers. If I plug in 0 for n into this one over here, that's supposed to be a 2 pi n, believe it or not. So if I plug in 0 for n there, I'm going to get negative pi over 3, which is actually on this graph here, it's just this location right here. The x coordinate at that spot is negative pi over 3. But if I'm trying to get the answers that I have highlighted here, then I only want the positive ones, so I'm not going to list that one off. So now I'm going to plug in 1 for n into each of these expressions. Well, if I plug in 1 for n, so pi over 3 plus 2 times pi times 1, pi over 3 plus 2 pi, with a common denominator, pi over 3 plus 6 pi over 3 equals 7 pi over 3. And again, we can see that that is indeed one of the answers that we have highlighted on that graph. It's one of those points where those two lines intersected. If I plug in 1 for n into the other equation, I've got negative pi over 3 plus 2 times pi times 1, so negative pi over 3 plus 6 pi over 3 is 5 pi over 3. And so that too is one of the values that was circled there on the previous slide. And so we could keep on going, plugging in larger integer values for n. We could plug in 2 for n, we could plug in 3 for n to continue generating more specific values in our list. So a lot of heavy lifting there, but the bottom line is that I want to review is, number one, to solve these equations algebraically, the first thing we've got to do is we have to isolate the cosine function or the sine function or the tangent function. We have to get that by itself, treat it like a giant variable that we're trying to isolate. Then, once we've got that trig function isolated, in the case of cosine, we take the arc cosine of both sides. If it was a tangent function we were isolating, we would take the arc tangent of both sides. And so that's what we did right here, is we took the arc cosine of both sides, and so then the arc cosine and the cosine cancel out, isolating the x, and then on the other side we have the arc cosine of whatever number we had on the other side of the equation, so arc cosine of 1/2. And so then at that point, we're going to, so that isolates the x. And so then we've got to apply this definition of arc cosine that's based off of the inverse cosine that then generates that infinite solution set, which we got in the box here. And then from there, if we want some specific answers, either for the most part for us, that'll be the answers that are between 0 and 2 pi, or if we're asked to list off the first 4 positive answers or something like that, then we just start plugging in values of integer values for n. Start with 0, plug in 1, plug in 2, and then we just plug those into the 2 parts of the infinite answer set to generate this laundry list of individual answers.